Okay, we continue on the graphical methods, okay, to determine the active force, PAE. Okay, so actually the graphical method has been developed by Kuhlmann, okay, to determine the PA, okay, for behind a retaining wall, okay. So a modified form of Kuhlmann graphical construction for determination of the active force, PAE, okay, per unit length of retaining wall has been proposed by Capilla. Okay, so this guy has improvised the Kuhlmann method. Okay, uh, by using the Kuhlmann graphical method, so he determined the PAE value. Okay. So in order to understand this, consider the force polygon for the which ABC, okay, as shown in figure 8.2 that was discussed previously. Okay. So for convenience, this has been replotted in figure 8.9a. Okay, the force polygon can be reduced to force triangle with the force PAE, F, and W. Okay, so this is the new equation, okay, after they have simplified the figure 8 point A. Okay. So this is the one that we have discussed previously, 8.2. Okay. So then they come up with another approach, okay, by introducing this new force polygon, okay, to determine the PAE. Okay. So from this type of the force polygon of the A, so they introduce the W, okay, to replace this part. Okay. Okay. Note that in figure 8.8 and B, alpha is the angle that the failure wedge made with the horizontal. Okay, so the alpha that we seen here, okay, is the alpha that we have discussed previously in this alpha in this failure wedge degree. Okay. So the idea behind the graphical construction is to determine the maximum value of PAE by considering several trial which, okay, with reference to figure 8.9c, following are the steps for the graphical construction. Okay, so now we look on this graphical approach. Okay, so there are several steps here, okay, that we may use to determine the PAE value. Okay. So basically, this is the same procedure with the Kuhlmann. Okay, however, it's been improvised by Capilla. Okay. So the actual what we call is the actual retaining wall. Okay, is from A to B. Okay, and the backfill is from A to C4 line. Okay, so this is the backfill. Okay, now we need to construct this what we call as this uh, line, okay, to determine the PAE. Okay, so we need to look on the procedure. Okay, so this is the procedure for the by using the graphical construction. Okay, to get the PAE. Okay, first draw line BE. Okay, so where is the B? Okay, this is the BE. BE. Okay, so this is the line of BE. Actually, it is based on the phi minus theta. Okay, so we need to get the value of we already know the value of the phi. Okay, so then this theta, okay, is obtained from the previous equation that we have learned. Okay, this is the theta. draw a line BD, okay, which make an angle of 90 minus beta minus delta minus theta with the line of BE. Okay, so firstly, we need to draw these problems uh, at a graph paper, okay, or a grid paper. Okay, so we need to draw this problem at the graph paper because we need to use the scale. Okay, okay. So the first step is this one. Okay, but we need to determine first the what we call as the theta. Okay, so the second step is the BD. Okay, so 90 minus beta, so this is the beta. Okay, minus delta and also minus theta. Okay, so that is the second line. So we need also to have the protector as well. Okay, to draw the BE and also BD. Okay. Okay. So then draw BC1, BC2, BC3, which are the trial failure surface. Okay. So the next is to just to draw. Okay. Uh, for example, from A and the line of A. Okay. So to make it easy. Okay. So we put, for example, two, 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 two for okay. This is just for example, 2 centimeter distance. For example. Okay. So from there, we draw a line from B to C1, B to C2, B to C3, and B to C4. Okay. Okay. So that is the 1, 2, 3. Okay. So that is the 3 step. Okay. Where we draw a line of B to C1, B to C2, B to C3, and B to C4. Okay. Okay. So determine KH and KV, and then square root of 1 minus KV square plus KH square. Okay. So this is based on the calculation only. Okay. To get the KV, KH and KV value. Okay. Okay. So from there, okay. So the fourth step is to only to determine to get the value. Okay, for the 1 minus KV square, and also you have to get the value of KH and KV, then get the value of this value, because later on we may use this value to get the WI prime. Okay, so determine the width, okay, W1, W2, and W3 of the trial failure, which ABC1, ABC2, ABC3, okay, respectively, per unit length at the right angle to the cross section shown. Okay, so then, okay, the next step is to get what is the value of the W. Okay, ABC, C1, C2, this value ABC1. Okay, so that is the ABC value, ABC1 value. Okay, so then ABC2. Okay, then get the value of ABC3. Okay, and the last one, get the value of the ABC4. Okay. Okay, so note that W1, okay, area of ABC times with the unit weight and time 1, because it is a two-dimensional diagram. So there will be no we refer as a per meter run. Okay, so from there we calculate for the W prime 1, okay, W prime 2, and so on. Okay, for the W3 and or W4, for example. Okay, so the equation will be like this one, okay, which is square root of 1 minus kv square plus kh square times w1. So that is for the w1 prime. Okay. So then adopt a scale, okay. So using the load scale adoption, okay. So then we just uh, produce a scale, okay. For example, 1 centimeter equal to 2000 kilonewton per meter or square, okay, or 1 centimeter to 2000 uh, kilonewton, for example, okay. Or we use whatever scale that we are prefer, okay. But within the range of the W, okay. For example, if the W1 we obtain 5000, okay, and then W2 we obtain 7000, W3 we obtain 10,000, W4 we obtain 12,000, 13,000. So we use a scale of 1 to 2000, 1 centimeter to 2000. Okay. I will show later in one example. Okay. Okay. Then using the load scale adopted in step 7, draw BF1, okay, BF2 and BF3 on the line of BE. Okay, so now we look on the BE, the step number 8. Okay, step number 8. Okay, so based on the scale, okay, so B B to BF1, okay, means that it is the distance, okay, from 0. Let's say your W1 is equal to 10,000, okay. So 1 centimeter is equal to 2000. So you need to have a 5 centimeter, okay, of the F1. Okay. Same go with the B to F2, okay. So you need to have the same scale, okay, for the F2, and same scale for the F3, and same scale to the F4. Okay. Then draw F1 G1, F2 G2, F3 G3 parallel to the line BD. Okay. Note that the BF1 G1 is the fourth triangle for the trial wedge ABC1, smaller to that shown in, okay. Similarly, B2, BF2 G2, BF3 G3 are the fourth triangle for the trial wedge, okay, ABC respectively. Okay. So the next step is to draw the F1 G1. Okay, so where is that? Okay. So from here, okay, sorry. Then we already know what is the F1, position of the F1. Okay. So we should draw a line, okay, until it meet the C1 line, C2 line for the F2, C3 line for the what we call for the F3, C4 line for the F4. Okay. So the line should be parallel to the BD. So BD is here. Okay. So it means that we need to make sure that, okay, the F1 line to the G1, which is meet the C1. Okay. So this is the F1. We need to draw a line until it meet the C1. Okay. But we need to make sure that it is a parallel to the BD. Okay. How to use the parallel? It should be parallel, okay, with the BD. Okay. Same go with the what we call it with the F2 to the C2 line. So it also should be parallel. Okay. Okay. So that is for the line of G1, G2, G3, and G4. Okay. Okay. Join the line, join the point G1, G2, and G3. Okay. So we need to join the line by a smooth curve. Okay. So might be you can use what we call a plastic ruler that can be curved. Okay. So then you join all the line by using a plastic ruler. Okay. So we obtain the step number, what we call step number 10. Okay. So this is step number 10. So then draw a line HG parallel to line BE. Okay, get G B point of tangency. Okay. So then draw a line HG. So where is the HG? Okay, HG. This is the HG, which is parallel to the BE. Okay. Okay. So this is the step number 11. Okay. To let G be point of the tangent. Okay. So then make sure that the uh, this smooth curve, okay, have a tangent of G. Okay. So then, okay, draw line GF parallel to BD again as well. Okay. So then this G, which is tangent to the HJ, okay, then this point should be draw uh, parallel. We should create a parallel line, okay, from the G to the BE line, which is parallel with the BD. Okay? So then we may obtain the F point. Okay. So the F point, okay, is the force PAE, okay, that we that we want to determine. Okay. So that is the this is the F is equal to the PAE. Okay. So it's very a little bit uh, complicated to understand, but if you follow the procedure, okay, so I guess you can get uh, the value for the PAE based on the graphical methods. Okay, so that is the PAE value. Okay, so I will show with you one example. Okay, however, this example related to the uh, static approach. Okay, let me uh, share the example based on the static approach. Okay, so this is based on static approach. Okay, the only different based on the dynamic is by introducing the K, the theta, and also the what we call the KV and KH. Okay, okay. So this is the procedure, the same procedure. Okay, so we look on this example. Okay, how they come up with the solution. So from A, okay, we look on the example of A. Okay. Okay, so this is based on the problem of A. Okay, so we look on this first on the gravity wall. Okay. So the difference is the theta. Okay, for example, first we need to construct for the AC. So AC, this is the phi value. Okay, because in what we call it um, in the dynamic problems. So we should reduce with the what we call it reduce with the uh, theta. Okay. So this is only phi. Okay. So for the static, however, for the dynamic, phi minus theta. Okay. 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 So we look on this example. Example 12.9. The same condition. Example 12 was not be included. Okay, this is what I mean. Okay, the scale that you may introduce. Okay, for example, but this is in pound. Okay, so 1 inch is equal to 5,000 pound per feet. Okay, so in your approach, okay, you may come up with your own scale. Okay, for example, 1 centimeter equal to 2,000 kilonewton per meter square. Okay. 2,000 per meter, sorry, because this is in loads. Okay, but 2,000 per meter. Okay, so this is the way how they what we call it, they calculate for the W. Okay, which is W for this case half times 120 is this is the unit weight unit weight of the soil. Okay, times feet, 5 feet times 20. Okay, so once you use the graph, what we call as the graph paper, so you can get the actual height and the actual width of the triangle diagrams. Okay. So for each W1, for example, then you draw on the same scale, okay, with this line, okay, and then make sure that the line is parallel with this last line, okay, the line at the bottom of the retaining wall, okay. And then make sure that this line later at this point later on connected with the C1, okay, for the first W1. For the W2, it is connected with the C2, okay, and for the for the W3, it is connected with the C3, okay, and the W4, it is connected with the C4, and make sure that it's parallel with the the, the line, this line, okay. Then by using what we call as a ruler, a plastic ruler, okay. So make sure that all the line is connected with all the point, okay. And then, okay, draw a line, okay, which is parallel with the line of this one, okay. By knowing, by getting the tangent of the point uh, from the curve, okay, then you draw a line which is parallel to this line, okay? And then you can get the PA, for this case, PA value, okay. So for our case, the line, the point will represent the PAE, okay. So I have shared this example in what we call in the e-learning, okay. So you may look on this example and try to relate with the capilla approach, because I didn't have the example based on the capilla. So I get it. This is from the static approach from the Coleman. Okay. So that is for the lateral stress for the PAE by using the graphical methods. Okay. So we have complete uh, the chapter for the lateral earth pressure. Okay, we have discussed by using the mononobe or Kabe, okay, and then it's been improvised by Aragon, okay, for a normal, for a simple, for calculation, okay, based on the static column lateral stress theory, okay, and then I have discussed also on the graphical methods, okay, by using the capilla approach where he has improvised the Coleman methods. Okay, so we take a rest for 5 minutes and then we may discuss on the brace cut uh, chapter.